Alright, it's been several months since I made my 5-inlet cyclone for the Milwaukee backpack vacuum. It hasn't really worked out very well. It's not very obvious here, but these ports actually collect quite a lot of dust and block up. And overall the performance wasn't great, it didn't filter very well. Now, I was testing the forged battery for balancing, but that's taken a long time, so in the meantime I had some time to do non-electronics work and created this kind of rocket engine looking thing. It's a multi-cyclone version. There's 34 cyclones, so I think 15 on the top, 19 on the bottom, and it's kind of beautiful. It's, yeah, lots of crazy stuff going on. So the 19 cyclones here, this is your main inlet port. So, if you look at the canister there, that's your inlet port, and that's going to go straight into there. Direct all the gunk into this inner collection chamber, which has got a mesh. I don't know if we'll be able to focus on it, but yeah, I've put this little sort of diamond mesh in to let small particles go through, and then the small particles go through these 34 cyclones. So the bottom ones, these ones might be the easiest to see, but they go in, swirl around, drop any dust into these collection chambers for the fine dust collection, and then they get this complex ducting going up here. These four in particular are kind of hard because they need to avoid this inlet, and I don't know how well you can see down the top there, but right in there I've merged these two to try and reduce the resistance and whatnot and just make it fit into a smaller area. Whereas all these other ones, so this cyclone here ducts up, and its duct, well, we'll talk this one, the duct fits in between the inlets of the upper cyclones. So we've got the upper cyclones here, 2 of them, and that's its inlet, or at least the top of it. I don't know if you can see in there, but it goes in there. And then between the 2 upper cyclones is the duct for one of the lower cyclones. And that will eventually go on to a second piece. This is just a test piece I printed. That'll be fully solid, and then you'll go in, there'll be holes there, and glue it on. So this is the original thing that slots into here, and those tabs line up, and I've recreated the top part of it here, and it doesn't quite line up yet. I need to tweak a few things. Just need to take a little bit off, move that a little bit that way, and then change the angle of that wall. Now, it was printed this way, with that as the bottom. So it'll actually go up that way. That's going to be the bottom, the collection chamber. This is the top, that's going to have the filter on it. But easiest to print it up that way for various reasons, just for the things, and I've had to add some extra little angly bits so that it didn't need extra supports. This bit was impossible to do without supports. I'm just about to start removing that. They're tree supports, and they should be pretty easy to remove. Hopefully we've got smooth edges on the inlet. Not so easy. This inlet is kind of a critical piece to make sure everything lines up, because we want that inlet to line up quite well with the inlet of this canister. Otherwise it's not going to work at all. The incoming air and crud is going to get blocked. And this incoming inlet was a bit of a tricky design to make sure it didn't interfere with the cyclones, because I was trying to pack as many cyclones in as possible. The more cyclones you can fit in, it's basically like having more parallel resistors, so it reduces the resistance to the airflow. So more cyclones equals better airflow, and much like more parallel resistors gives you more current flow. So the original vacuum had this thing with a whole lot of little holes in it, if you ignore that. It originally had a whole little holes in this black piece to let air through. That was a mesh. And that mesh area was 2,940 square mil. Now my new one, its mesh is 11,000 square mil. So hopefully that's not going to offer too much resistance. What is a little bit less is, so the 5 inlet design, which was my old mod, that had an inlet area of 2,250 square mil. And this new multi-cyclone has an inlet area of a bit over 2,000 square mil. So it's probably going to be equivalent to a bit better than, say, a 4 inlet cyclone. So we're going to take a hit there. The outlet size is bigger than the old mod. The old mod was a 50 millimeter diameter outlet, which gave 2,375 square mil. And this new one, which is 34 11 mil outlets, is 3,231 square mil. So bigger outlet, smaller inlet. Hopefully they kind of balance each other out, because if I get the same flow rate as the old mod, that will actually be pretty good, because the old mod had an okay flow rate. It was just disappointing in terms of its filtration. So what I'm hoping is we get the same sort of flow rate as the old mod, but much better filtration, and we'll get that really sort of flat performance curve where all the dust is going into these collection chambers rather than into the filter. Vacuum hose is going to go in there. It's unfortunately going to whack that thing pretty hard and do like a 50-degree turn. It's a very complex shape to get that to work. Yeah, head in like that into this inner cylinder, and it comes in nice and tangentially, so hopefully any heavy stuff isn't going to smack into this too hard. This thing's going to take a beating, and I'm inclined to stick a little bit of padding there. You might notice I've got a bit of mesh there, and that kind of is to let air through, but it's really just to strengthen that wall, having those cross lattices of the filament strengthens it. Whereas if I just leave that plain, then it ends up being gets filled with sort of partial infill. It's not solid. You get the inner wall, and the outer wall are solid, and then in between the 3D printer just fills in as little as it can. So that's actually what's happening here. You won't be able to see it, but that top is actually fairly hollow. And the easiest way was to just put a whole bunch of things in there, and a bunch of little through holes. And that serves the secondary purpose of letting more air through into this fine dust area. But I think once you start vacuuming up screws and stuff like that, you're going to want to add some foam padding in there to stop it from shattering that. So all of the collection chambers are isolated, and that's to prevent crossflow between the cyclones. The upper cyclones are going to have less resistance than these lower cyclones, and that's because they have a very short path for the air to go before they get into the filter part, because they're right up against it. Whereas the bottom cyclones have to go through this extra ducting, and that's going to add resistance. And if you have a resistance imbalance in airflow, then what will happen is this upper cyclone will tend to pull air down through its thing and through that, and you don't want that, because the dust is coming out of this lower cyclone and it's going to get sucked up straight up the inner cyclone and into the filter. We definitely don't want that. So I've isolated them all. It's not ideal because it means some of these collection chambers will fill up faster than others, but the only other way around that is to carefully tune your cyclones to have the same resistance. And Dyson have done that. They've changed the inlet size, so they've got their sort of a lower cyclones and some higher cyclones with different resistances, and they very slightly changed the inlet geometry so that they have the same resistance and that you don't get any of this crossflow between cyclones. But this thing takes 44 hours to print and uses 700 grams of filament, so I don't have that kind of patience to go through that tuning process. It would take probably 10 or so prints to tune. Now, the moment of truth, will it fit? Often 3D printing stuff requires a bit of tuning. I'm secretly hoping I've got it right. Looks alright. Does the inlet line up is the important part. Got a bit of an edge there. I don't know how well it'll show up. No, looks alright. I think I'm a tiny bit tall. By that I mean I think this piece is too high. This won't show it because this doesn't go down low enough, but well, actually will. There you go. See, that filter lid is touching on that surface. And we know that the filter lid needs to go down another mil and a half. So I'm going to have to shave a bit off the bottom. I think maybe half a mil to a mil. So I'll correct the 3D model for the next print if I do another print. But for now, I will probably just sand the bottom off. And I don't know how well this will show up, but right in there, it looks like it does line up. So that's the front edge just touching there. If I rotate it back a tiny bit, it all looks pretty good. There's some small gaps around the edges, but that's not a huge deal. I've been thinking I can potentially use some tape to sort of join this a little bit, to smooth that out, but if fine dust gets through that gap, that's not a problem, because this is really just a separator to stop big chunky stuff from blocking up the inlets of the cyclones. So if fine stuff gets through that gap, that's not a problem, because it's in the fine dust area. This inner area is sort of the big chunky dust area, and outside of that is the fine dust area. So I don't care if fine particles escape there, they're just going to go straight into the cyclones and end up in the collection chambers down the bottom. Alright, anyway, I guess I need to go buy some more filament, because this 700 grams ran me out, so I need to reprint this, sand that down, and we're testing. That'll be after Christmas. So Merry Christmas, y'all, and see you next year.